Okay. I am already recording. It didn't ask me my normal question. Do I want to use the microphone?
Oh, I thought you were.
No, I didn't.
Microphone's turned off.
Well, I didn't update this morning on the BenQ, so note to self, I need to listen to this video later to make sure it does record. It is recording voices. Otherwise, I have a big issue. Okay. We left off Friday on example 4, talking about Galileo and his rolling balls down an inclined plane. And on the calculators, we had entered the data, right? So if you don't still have the data entered, which I don't know why you wouldn't in all honesty, but just in case, make sure you get that data entered into L1 and L2 or wherever you're putting those in. And this must be the calculator I used in my afternoon class as well, because we got the points plotted, but we didn't get the viewing window adjusted. So if I go into stat and look at my list, my numbers are in L1 and L2, right? And then I had to go into second stat plot up here above y equals, just kind of reviewing because you're going to have to remember this. And I had to turn my stat plot on, right? So I had to go into stat plot 1, and I had to turn it on. And when I turned it on, I could also pick some different settings. Was it this class or my afternoon class? Like magenta?
This class.
Okay, it was this class. You know. Okay. And then we graphed it. And when we graphed it at the time, we're like, oh, we only have 4 points showing. Are there supposed to be more than 4 points? Yeah, there's supposed to be more than 4 points. But remember, they go up as high as 48, don't they? So this is when I went into window. Right here, window, and I changed some values, didn't I? Mm-hmm. I don't have anything negative, so I never need to go below 0. So I changed my x-min to 0. I think I left my x-max at 10. My y-min, again, I don't have negative, so I changed my y-minimum to 0. How far do my y's go? They go up to 48, so I'm sure I probably put 50 in. Mm-hmm. And then I hit graph, and I have all these lovely points, yes? Mm-hmm. Now, if you have a random line running through your screen, what does that mean? That means when you go over to y equals, you have something still on this screen. So if you don't want that line running through your screen, you either need to delete it out or to turn it on. Okay, so we have a graph that looks like this. Now, let's see. So the question is, what graphical model fits this data? And then we're going to find an algebraic model. So as you look at this, what shape do you see?
Almost like a half parabola.
Does it look like a parabola? Obviously just the positive half, yes. But it is just that. It is parabolic in shape. And so we're going to use the fact that it looks like a parabola to write our algebraic model. Okay, so I'm going to just over here in the corner kind of put a sketch in that, and we used something called stat plot. And I'm kind of, if nothing else, putting this vocabulary down in your notes. So when you go look at it in your homework, you say, oh, wow, how did we do that? You know, you have to look for stat plot. Along the bottom, along the x-axis, we had time, which is in terms of seconds. Along the left, we had distance traveled, which is in terms of inches. And I'm not going to take time to label this. I'm just sketching the graph, and so I'm just going to kind of show that we had these points. Okay. Points did something like that, right? I'm just kind of putting them in the shape, giving us the idea. And we just talked about how this looks like a parabola. Now, as we talk about it looking like a parabola, think equation for me. What does an equation for a parabola look like? What's that look like?
X squared is square root of x.
Okay, so x squared, right? So general parabola is y equals x squared, yes? Now, is it always exactly y equals x squared? No. Now, it does look like this is centered at 0, 0, doesn't it? So it's not going to have anything added or subtracted to it. Okay. However, does it have the typical width? Does it go through 1, 1, 2, 4, 3, 9? No, if you look at these values, it doesn't go through that, does it? And so we're going to use the idea for a parabola of that a value. That's the key we don't know. So this is of the form y equals ax squared, because it goes through 0, 0. It's a parabola centered at 0, 0. We just don't know how wide or narrow that is, right? So what is that stretch or compression? That's what we're trying to figure out here. Now, in order to do that, we have some other values that can help us. We do, don't we? Okay. I mean, we already know it goes through 0, 0, but besides that, we have some other values. And so the key right now is we need to find a. And in order to find a, we need to pick an ordered pair that we're going to use as x and y that we can put into the equation to find a. Now I'm debating, do I want to do this in terms of x's and y's or other variables? I don't know. Which variable or which ordered pair looks good to you guys?
2 and 3.
I wonder why you picked 2 and 3.
They're whole numbers.
Okay. Not decimals, whole numbers, right? 0, 0, does that help us?
No.
0, 0 is the one ordered pair you can't pick. I definitely would pick something that is whole numbers here. Now, we normally think in terms of x and y, yes? Where this top column is x, top row, and bottom row is y. And I'm okay with continuing with x's and y's. Or what is often used for time? T, and what would often be used for distance? D. So instead of thinking y equals x squared, we could also think, instead of y equals ax squared, we could think d equals at squared. And that's just taking it from the x's and y's and using d's and t's. Now, am I saying you have to do that? No, I'm not. I'm just trying to, help you be a little more comfortable there. So let's throw our values in. What's our d value? 3 equals a, which is what we're trying to find, times t squared. What's t? 2. So 3 equals a times 2 squared. Do some math. 2 squared is 4. 4 times a. If 3 equals 4a, then what do we know? A equals 3/4. Or, if you're not a fraction person, what's the other option you could say here? 0.75. In all honesty, I have both in my notes. So on something like that, I'd be fine with either or. It's a little bit different if it's 1/3, because 1/3 is a repeating decimal. So we have to be careful there. But okay, so if we want to write our equation, d equals at squared. So one way to write this would be d equals, I actually used 0.75 in my notes, 0.75 t squared. If you're more comfortable with x's and y's and you would go back to the beginning, you could say y equals 0.75 x squared. That'd be equivalent. Unless they tell you what variables you have to use, it doesn't matter. Okay? So, graphical model, this is a parabola. Algebraic model, well, there's the algebraic model for that parabola. So there's the algebraic equation. Now, try something. Go in your y equals screen and type in this equation we just came up with and then graph it. So if I type in 0.75 x squared and then graph it, what is it doing? Is it connecting those dots? Did it land straight in them? So what's that tell me? We were right. Okay? It is a parabola. By using one of those ordered pairs, we came up with the correct equation. Okay? So that's kind of a check when if you already have the points plotted and then you throw the equation in there, they can't overlap. Okay, questions here. Okay. Let's look down to example 5. Different, similar to what we just did, different twist on it. Use the table from example 2, which I think is from Friday, which is the incarcerated prisoners. Okay. To model the growth of female prisoners with an equation. Create a graph by using the percentage of female prisoners in the prison population T years after 1980. Now, these are not the exact numbers we would have had. I mean, yeah. I don't have them in my chart anyways anymore. So we're going to use the values they have here. Okay. They give us T in terms of years. So those are years after 1980. And F being the percentage of females in the prison population. Okay, so what do we need to do first? We need to put these values into the table, yes? Where do you want to put them? L1, L2? And here's what I'll say about that. Sounds like a great place to put them to me. If you already have things in L1 and L2 and you want to use L3 and L4, could you do that? You could. Okay. I'll be honest, I'm going to change calculators because that way I can have them both ready to go for this afternoon. Now remember, if you want to clear out a whole column, you do clear enter, correct? And the top, if you want to clear out. Don't delete, or you will delete the whole column, which is not a good thing.
Where even is delete button?
So L1 is 0, 5, 10, 15, 20, 25. What?
I think it's right. The delete button's right under Zoom, right?
Yes.
Oh, that's what it is. Okay.
Yeah, DEL. Okay, you got your L1 and L2 entered. Now, you can go ahead and try and hit graph. However, realize there are some adjustments that are going to have to be made. Because if I hit graph right now, is my window going to be on good settings? I mean, oh wait, I'm on my other calculator. I switched calculators in the process. That was probably not a good thing. Now, your calculator probably looks a little different than my calculator, right? I go and change, let's see. You probably have something more like that, don't you? And do you have a parabola going through them too? Okay, so a couple of things. First of all, did you go to y equals and delete your equation? Or turn it off? Okay. And then when we look at our graph, why am I only seeing like barely 3 points and I should be seeing 6? We need to change those window settings, don't we? So when I go into my window, let's see my x's. Those are my t values, aren't they? And they actually need to be 0 to 25. Or I think I might do 0 to 30, honestly. My y's, 3.9 to 7.1. That personally sounds like a good 0 to 10 to me. So 0 to 50, 0 to 10. If I hit graph, is that something a little bit better? Now we can actually see all 6 points. Okay. Do we have another parabola going? No? Like a scatter plot almost?
like what's the name for a scatter plot with the points? Like you can put a line through it and it will hit.
So you're thinking it's similar to a scatter plot, but there's a correlation here is what
Like
I
if you
think
put
you're.
a line right there,
Okay.
it could either not. It wouldn't go through all of them.
But it would go through a lot of
They're
them.
all like correlated.
So what does this graph look like? What is it similar to? Is it linear?
Yeah. Yeah.
It is. Okay, now that parabola was exactly a parabola. This one, is it going to be exactly a line? No, not exactly. Can we get a line in the ballpark?
Yes.
Yes, and that's what we're going to do here. So, again, I'm going to put a little sketch over here. And the idea that this is t-axis, this is f-axis, and we have 6 dots going across the way, right? Okay. This is going to be linear. So when we ask about, what graphical model, it's a linear model. What is our equation we want to think when we talk linear? Yeah, when we talk linear, we generally think y equals mx plus b. So, with that in mind, our job or our goal is to find somewhere there's a linear line, that is very repetitive, a line that goes through the middle of those points. Well, what do we need to write a line, write the equation of a line? We need a slope. In order to need a slope, what do you need to find a slope? 2 coordinates, yes? Okay, so with that in mind, we need to pick 2 points. And I don't know that I have a right versus wrong answer to tell you here about, which 2 points should we pick. I will say there is one definite specific point I would pick. What is the importance of picking 0, 3.9? It's what? Okay, it's not 0, 0.
It's your y-intercept.
Oh, is it my y-intercept here? Am I making life easy if I go ahead and do that? Okay, so by picking this, I have my y-intercept. Okay, is it always going to be that easy? No, but we'll enjoy it while we can. And in all honesty, I can't see my graph turned off, but as long as the point does not look crazy out of whack, if that makes sense, you can really pick any other point. I'm going to go for the other end point is what I'm going to go for. And so we're getting the 2 endpoints here. So I'm using 25 and 7.1. So thinking of my ordered pairs of 0, 3.9 and 25, 7.1. This is a situation where our answers would vary slightly if we don't all pick the same points. The parabola, they would all be the same. So, did you find slope? Let me rephrase that. Are you finding slope? How are you finding slope? What was it? Okay. She says 7.1 minus 3.9, because we're going to do y minus y over x minus x. Must be 25 minus 0. I'll give you 3.2 over 25. What's the calculator say?
Zero.
0.128. Okay. So if our slope is 0.128, and we already have our b as 3.9. Can we write an equation? Okay, what equation could I write? Y equals 0.128x plus 3.9. Officially, did they give us other variables other than x and y? In the table, it was labeled as t and f, wasn't it? Could we use t and f instead? Because that means t would be our x value, f would be our y value. So you could also say f equals 0.128t plus 3.9.
On the test, will you care?
I'm usually very flexible about variables. I mean, as long as they make sense. Now, if you take things like x and y and flip-flop them, then I have to be a little particular. You know, you can have x equals with the y in the other spot. Okay. That's a little bit about how to use that stat plot, how to graph with points. Now, before I walk away from the calculator, because I'm not really using it well, we might use it later. If you go to do something else on your calculator, and do you always want the stat plot on? Well, I wish we could always leave the stat plot on and just leave the points. However, if you leave the stat plot on, sometimes you get errors. Not always when you go to graph things, but sometimes you'll get errors. Now, there's two ways to turn it off, or on and off. And if you want to leave it on for right now, you're probably okay. But you know how I showed you to go into second stat plot to mess with the settings? I never noticed this until last year, I think. And I've been using this calculator for like half a dozen years at this point. But notice above the y equals, what do you see here? Plot 1, plot 2, plot 3. If you don't need to change any settings, you can go up there and turn your plot 1, plot 2, plot 3 on and off. Now, obviously, you can't change settings there, right? But as long as you want plot 1 to stay and be L1 and L2, you can just go right there and turn it on and off. It's just a toggle. Okay, so just, you know, and if you get an error, and you know, I know a lot of times you guys just see error and you don't even read it, but if you read it and it says something about stat plot within your error, that's just saying your stat plot's on and it's causing an error of whatever you're trying to graph. Okay? And again, sometimes it works, sometimes it doesn't, so. Okay. We're going to set the calculators aside for a moment. We're going to talk algebra. Okay? Because with this last page, it's solving some equations, some kind of more difficult equations, right? We're going to practice a little bit of algebra skills. We're also going to practice some graphing skills, though, with the calculator graphing skills. Okay? The fun kind of graphing. So, example A, 6x cubed plus 11x squared plus 10x. And notice the directions say algebraically. So no, we can't put this on a graph. Thoughts on what to do to solve this algebraically? Okay, equal to 0. If we equal it to 0, no, it's Pocket is talking to us. Okay, if we equal it to 0, I like to keep my first term positive. I'm not saying you have to. So I'm going to subtract 11x squared and subtract 10x. That's my way of doing things. Yes, it means I have to subtract two things, but I'm okay with that. So 6x cubed minus 11x squared minus 10x equals 0. Okay? What do you notice? Thoughts on the next step? What? Pause on the product of AC. I'm going to come back to that. We can't use product of AC yet, though, because is there a GCF? And it's not because there's a GCF we can't use it. It's because product of AC works when it's x squared is our highest term. Right now we have our highest term being x cubed, so technically we can't use product of AC, but there is a GCF. All three terms divide by n, x. Now, don't divide x away and drop it out of the problem, because that x is one of my answers. So you want to factor it out front as a GCF. When I factor x out, what does my insides become? Okay, so we have x outside, 6x squared minus 11x minus 10 on the inside. Now, your goal is to not lose the x as we proceed. It's a difficult goal, okay? Now, how do we factor that 6x squared minus 11x minus 10? And now I'm ready to entertain the idea of product of AC. Because it is an x squared x constant setup, and there is a value in front of a. So, I'm going to do my product of AC over here. So if it's product of AC, what are A and C? 6 and negative 10. So that's negative 60. And a sum of B, what's B? Negative 11. So I need a product of negative 60 and a sum of negative 11. And that's where I go through my list. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Which pair is possibly going to work? I think 4 and 15 were the only ones that had a difference of 11, weren't they? Mm-hmm. Okay. How do you multiply to get negative 60 and add to get negative 11? 15 is our negative value, correct? Okay. So, this x out front, carry it down. Okay? And then the negative 11x is going to split, correct? So I'm going to officially carry my 6x squared down. Minus 11x splits into that 4x and that minus 15x. I don't think it really matters here, does it? So I'm going to say plus 4x minus 15x. We still want to carry down the minus 10. And we're going to enter our parentheses and still equals 0. Okay, I'm going to be moving over here. The x out front, carry it. And I'm going to put brackets here because we're going to get into a situation where we've got parentheses and brackets. How do we factor? We've got 1, 2, 3, 4 terms. Take 4 terms and split in the middle. So what is the GCF of 6x squared plus 4x? 2x. So I'm going to put that inside my brackets. Then after the 2x, 6x squared divided by 2x is 3x. 4x divided by 2x is 2. GCF of the second half. Negative 15x minus 10. What do they both divide by? 5 of the negative variety, please. Because both terms are negative, we need to divide by negative to make this work out. So, minus 5. Negative 15x divided by negative 5 is going to be 3x. Negative 10 divided by negative 5 plus 2. I can end parentheses. I can end my bracket. What am I going to say about this x out front? Carry it down. And then, do you see your 2 parentheses? the matching parentheses. So 3x plus 2 is the GCF there. And then the GCFs from previously, or the leftovers, 2x minus 5. And officially, when we moved over to this side, I dropped off the fact that my equation officially, this is an equation, right? It equals 0. Am I done? No, we're told to solve. X equals what? So what do we do here? Yeah, set each part equal to 0. There are 3 pieces multiplying, so we're going to set each of these 3 parts equal to 0. So we're going to have x equals 0, 3x plus 2 equals 0, and 2x minus 5 equals 0. Can you handle it if I don't show the work here? X equals 0. What else? Negative 2/3 and positive 5/2. If I say it's logical that we have 3 answers, why is it logical we have 3 solutions here?
Because we have 3 x's.
Yeah, this is x cubed, wasn't it? When your highest power is x cubed, there can be up to 3 real solutions. Okay, so we have 3 real solutions here. Okay, B. B has a radical. We gotta change our game now. If there's a radical here, how are we gonna deal with this radical? What? Eventually. She says square everything. I'm going to say eventually. We are going to square to get rid of the radical, but not until the radical is by itself. So your first job, when you see a radical within a problem, work to get that to be the only thing on that side of the equation. So in this case, to get this radical by itself, since it's square root of x plus 1 plus 3, I'm going to subtract 3. So now, I have square root of x plus 1. When I subtract the 3 over, it equals 2x minus 3. Now I have the radical by itself. Now that the radical's by itself, now we can say we're going to square it. If we square the left, we're going to square the right. What is the square root of x plus 1 squared? X plus 1. What is 2x minus 3 quantity squared? Here's the key. Is it just 4x squared plus 9?
No.
No, you're going to get yourself in trouble if you just tell me it's 4x squared plus 9, because you're forgetting the middle term. 2x minus 3 quantity squared is 2x minus 3 times 2x minus 3. And how do we multiply 2x minus 3 times 2x minus 3? We FOIL, don't we? Okay, so if you just tell me 4x squared plus 9, well, you've got 2 of the 3 terms. So 2x times 2x is a 4x squared. We have a minus 6x and another minus 6x, which is going to make minus 12x. Minus 3 times minus 3 is plus 9. Okay. Thoughts from here? What'd you say? She doesn't want to repeat. I said, what'd you say? What?
Get it equal to 0.
Can we get it equal to 0 and see what we can do with it? It's going to be a quadratic there, so we can look at our different options. So I like to keep my positive x squared. Personal thing. So I want to keep 4x squared as positive. So in order to do that, I'm just going to subtract x and subtract 1 over to the right. So x minus x will cancel, 1 minus 1 will cancel. On the right, I have 4x squared minus 12x minus x is going to be minus 13x plus 9 minus 1 is 8. You say ooh?
Yes.
Okay.
Because it looks so good.
Well, what are my options here? Okay. So if we try product of AC, we need a product of 4 times 8, which is 32, and a sum of negative 13.
Well,
1 and 32. No. 2 and 16. No. 3 doesn't go into 32. 4 and 8. No.
Let's just do distributed.
5, 6, 7, 4 and 8 is our middle set. So, product of AC, this doesn't factor. We tried, and was it worth a try? I would say yes, because you never know. So, what's the next plan?
quadratic.
Quadratic formula?
I almost called it distributed. Like that's
No. Quadratic formula. If all else fails, we're going to go for quadratic formula here. So, x equals negative b. So the negative of negative 13 is 13 plus or minus the square root of b squared. So realize that's negative 13 squared. It's got to become positives. Minus 4 times a is 4 times c is 8 all over 2a, 2 times 4. 13 plus or minus whatever 169 minus 16 times 8 is. I have 41 written down on my paper.
Yeah.
Okay. Now I'm just going off the notes. I didn't plug that into the calculator. Now, do realize, and this is speaking from the test that I graded over the weekend, this 8 goes under everybody, yes? It's not just part of it. It goes under everybody. What do you know about the square root of 41? It's a prime number. It's 1 times 41. So this answer, or about the only thing you can do with this, is to split it up and say 13, whoops, not 13 whoops, 13 eighths plus or minus the square root of 41 over 8. You could split it up into 2 if you needed to. You could leave it here. You could go a decimal route if they asked you for a decimal route, couldn't they? Couldn't you? But we can also leave it like that. Okay. With this in mind, I want to talk about A on the next set real quick. I know I'm about out of time. Bear with me here. But the rest is all about solving graphically. In homework, if it says solve algebraically, what do I want to see in your paper? I want to see the algebra, yes? Now, if it says solve graphically, there's not as much work to show, is there? If we solve something graphically, that means we need to be able to plug it into the calculator. Now, can I plug this as is into the calculator? No, it needs to be y equals. And I believe the book and their directions will say to set your equation equal to 0 on the right or something like that. I can't remember how it reads. But we're going to make this equation equal to 0 so we can plug it into the calculator. I'm not going to do any work with this by hand. I have a square root and an absolute value. Can I do anything with that mess? No. So what I'm going to do is I'm going to subtract 3 square root of x plus 6, that whole expression, over to the other side. So then I'm going to have absolute value of 2x minus 1 minus 3 square root of x plus 6 equals 0. Now do I have something I can plug into the calculator? Yes, so what you're going to plug into the calculator is y equals absolute value of 2x minus 1 minus 3 times square root of x plus 6. You would type that whole thing into the calculator. And then here's the big question. Where do we find our solutions? Our solutions are where the graph does what? Crosses the x-axis, horizontal, think x-axis here, okay? So your solutions are where the graph crosses the x-axis. So you're going to put your equation equal to 0. You're going to graph y equals, and then look for x-intercepts. Do you remember how to look for x-intercepts on your calculator? X-intercepts, what's another word for those? Zeros. Okay. Start into the homework. Okay. See what you can do with it. We're going to do a little bit more with the graphing tomorrow here, but I also want to be able to take some homework questions from you. Okay. So thank you for bearing with me. But do look at the homework. I won't have it due at the beginning of the class by any means, so. Okay. And have a good night.